2.6, we're supposed to write an expression for the distance between the origin and any point on this curve, which was y equals x squared minus 8. A parabola moved down 8. And that's, they gave us that. I drew a graph of it. And any point on the curve could be xy, and the distance formula says it's the square root of the changes in x. So I find the difference in the x's, so x minus 0, which is just x squared, plus the change in the y's, which is y minus 0, or y squared in this case. But it's supposed to be the distance as a function of x. Well, this has x's and y's. So we have to remove the y, and it says y right here is equal to x squared minus 8, so we can change this to say the square root of x squared plus y squared. And that would be a formula. Then if you want to know how far away it is when x is over here at 1, we put in 1 for the x, or put 2 in for the x. And we were supposed to do that for a couple of different things there. I think we were supposed to do it if x was 0. We should get 8 away. If I put 0 there, I get 0. If I put 0 in here, I get minus 8 squared, which is 64. Square root of that is 8. So I get 8. If I put in 1, I should get about 7, a little over 7. 1 squared is 1, plus 1 minus 8 is 7, squared is 49. 1 plus 49, that'd be the square root of 50, which is about 7. And then it says graph it with a graphing utility. And we did this in class. You just turn it on, you push y equals, and you type in the square root of x squared plus parenthesis x squared minus 8 quantity squared close the square root. If I do zoom 6, I get this, and it says the distance decreases, distance between the 2 points decreases as you come down to around this x value, and then it gets bigger again, gets further away, and then it gets shorter, and then it starts getting further away. And they want you to find these minimums, which you can do by pushing second trace, find the minimum. And I'm going to find the minimum between 2 and 4. 2, enter, 4, enter. So I'm looking for a minimum between here and here. And my guess is about 3. And it says, no, it will happen when x is 2.73. X equal 2.73, or, since this is symmetric, at x equal negative 2.73. And the minimums, the actual distance, would be 2.78 in both cases. Next one says find the area of this rectangle as a function of x. Well, a rectangle is base, which it says it's over x. According to that point, it's x. Width times height, or length times width, and the height is y. But that's not a function of just x. But y, any point on the curve, the y coordinate has to be 16 minus the x squared. So replace the y with, leave that x there, and replace the y with 16 minus x squared, and that's the area of that rectangle. Then it says, what's the domain? Well, x, the distance over, has to be somewhere between 0 and 4. So the domain would be from 0 to 4. And graph it, and what is the largest? And so you would just type this into the calculator and graph it and find out what x gives the largest area. This one said find the area as a function of r, of the square. A square is a rectangle. You take width times length, or length times width. You just have to figure out how this is an r. Well, if that's the radius r, that's also a radius r, and that's a radius r, so this length is r plus r, 2r, and the height will be r plus r, 2r. The area is going to be those multiplied, so it's going to be 2r times 2r, which is 4r squared. Perimeter, we're just going to add up 2r plus 2r plus 2r plus 2r, 8r. That's it. I think I did that mostly off the picture here. R and R, so this length is 2r. R and R, so this length is 2r. The area would be 2r times 2r, 4r squared. The perimeter would be 2r plus 2r plus 2r plus 2r, or 8r. 20. It says write the volume of the cylinder, and they gave you the formula, as a function of h. Well, right now it's a function of r and h. Pi is a constant, but r and h can vary if we move this point to different places and get different shapes of cylinders. So the volume as a function of h is pi. We need to replace the r squared with something, h. And if you look at this picture, you can see this triangle here. It's a right triangle, so Pythagorean Theorem works. The leg is r, little r. The height is not h, but h in half. So the Pythagorean Theorem says leg squared, little r squared, plus leg squared, 1/2 h quantity squared, equals capital R squared. Leg squared plus leg squared equals hypotenuse squared. We're trying to replace r squared. There's r squared. If we were just to subtract this from the other side, we know what to put in here. 1/2 h squared minus, r squared, capital R squared, minus 1/2 h squared, times an h on the outside. We can leave big R in because it's a constant, but we need to get rid of the little r because it's a variable. It changes as we change the position of the point. That's 20. 21, we're supposed to rewrite this formula for this inside the cone, where we only have r's. So we got to replace the h this time. And if you have to look at the picture for a little while to figure out how this works. We can't use the Pythagorean Theorem again because we don't know hypotenuse there or hypotenuse there. But we can use similar triangles. We have a big triangle, which is long leg is h, and the radius is r. Those are constants, so we can have those in our equation. And we have another triangle up here that's this length is the capital H minus little h is how tall that is. So, and since similar triangles are proportional, we can use capital H minus h over little r. And we're trying to solve for h, so I'll multiply by little r. And then I'm going to move the subtract h, I'm going to add it to both sides, so it becomes positive. And I'm going to subtract this from both sides, so it's taken away from the capital H. And that's what I'll put in place of the h to get the formula in terms of little r, some constants, and r squared here. So the volume would be pi r squared times capital H minus R capital H divided by capital R. The only variable here is the little r. Everything else is constant. And finally, 25 says we got cardboard or whatever it is. We're cutting the corners out. We're going to fold here and here to create a box. And the volume of box is length times width times height. But we're supposed to have it in terms of x, the size of square we cut out of the corner. So the volume as a function of x is going to be length. That would be from here to here, because we're going to fold this up, which is 24 minus x and minus x. So the length is going to be 24 minus 2x. The width is also 24 minus x, and I have to multiply it, so that would be just another one of these multiplied. And then the height will be how high this folds up to, which is going to be just x high. So that would be the formula. And then they said, how much would there be if you put in, cut out a 3-inch square? So you'd do 24 minus 2 times 3, so 24 minus 6 is 18 squared times 3, and that would be get you the answer for B. And what if you did a 10-inch square? So 2 times 10 is 20. 24 minus 20 is 4. 4 squared is 16 times 10 would be 160. That would be the answer to C. I didn't do B, but you get the idea.